Ladies and gentlemen, tonight we step into a chapter of aviation history where speed, versatility, and sheer industrial ambition collided at 300 miles per HR. We are talking about the Junkers Ju-88, an aircraft so adaptable it became one of the most important multi-role combat planes of the Second World War. While another bomber earned the nickname Flying Fortress, there was, on the other side of the conflict, a machine just as determined, just as formidable, and far more flexible in its mission profile. Before we taxi onto the runway of history, make sure you subscribe to the channel and join our community of aviation enthusiasts. Your support keeps these deep dives airborne and prevents Timmy from attempting to build a replica cockpit in his garage using folding chairs and questionable wiring. The Junkers Ju-88 originated in Germany in the mid-1930s, a period when rapid rearmament and technological experimentation defined European aviation. Designed by Ernst Zindel at Junkers, Flugzeug und die Motorrennwerk, the aircraft first flew on the 21st of December 1936. It was conceived as a fast-medium bomber capable of outrunning contemporary fighters, fulfilling a requirement for speed and operational flexibility. Production began in earnest in 1939. Over the course of the war, more than 15,000 Ju-88 aircraft were manufactured, making it one of the most produced German aircraft of the conflict. Imagine an engine so loud it wakes up ancestors you didn't even know you had. This vintage beast isn't just transportation, it's a mechanical symphony of pure chaos and chrome. Hit that subscribe button, folks, because we're diving deep into the oily heart of another legendary rolling dinosaur. Technically, the Ju-88 was powered in most variants by two Junkers Jumo V-12 inverted V-12 liquid-cooled engines. Early versions produced around 1,000 horsepower each, with later models reaching approximately 1,100 horsepower per engine. The twin-engine configuration provided redundancy and increased payload capacity. The aircraft measured approximately 47 feet 1 inch in length, or about 14.36 meters, with a wingspan of 65 feet 7 inches, equivalent to 20 meters. Height stood at around 15 feet 4 inches, or roughly 4.67 meters. Empty weight varied by variant, but typically ranged around 20,000 pounds, or approximately 9,070 kilograms, while maximum takeoff weight could exceed 30,000 pounds, about 13,600 kilograms, depending on configuration. Top speed for early bomber variants reached roughly 290 miles per hour, or about 470 kilometers per hour. Later high-performance versions approached 310 miles per hour, approximately 500 kilometers per hour. Operational range was typically around 1,100 miles, or about 1,800 kilometers, again depending on payload and fuel load. Armament differed between variants, but bomber versions generally carried a bomb load internally, with defensive machine guns positioned in nose, dorsal, and ventral stations. Night fighter versions replaced bomb capacity with radar equipment and heavier forward-firing armament. The Ju-88 structure incorporated stressed skin all-metal construction, a hallmark of Junkers engineering. Its mid-mounted wing and streamlined fuselage contributed to aerodynamic efficiency. The cockpit, with its extensive glazing, offered excellent forward visibility, but also increased vulnerability. Timmy once told me that if he had designed the cockpit, he would have added cup holders and optimism. I gently reminded him that wartime design priorities differ slightly from road trip comfort. Landing gear retracted inward into the engine nacelles, reducing drag during flight. Dive bomber variants included dive brakes to control descent angle during steep bombing runs. Over time, additional armor plating and self-sealing fuel tanks were introduced to improve survivability. The Ju-88 proved resilient and adaptable. When bomber losses increased, the aircraft was converted into night fighter roles, equipped with early airborne radar systems to intercept enemy bombers under cover of darkness. This transition extended its operational relevance long after its original concept as a fast bomber began to fade. Bob, my conspiracy-loving neighbor, insists that early radar systems were secretly powered by moonlight. I explained that physics does not support that theory, but he remains committed. By the end of the war, the Ju-88 had become synonymous with versatility. It was not merely a bomber, it was a platform that adapted to strategic necessity, reflecting both engineering ingenuity and the harsh demands of prolonged conflict. And this, my friends, is only half the story. Design philosophy behind the Junkers Jumo V-12 was rooted in adaptability. While many aircraft of the late 1930s were engineered for a single defined role, the Jumo V-12 emerged as a modular platform long before the term became fashionable. Its internal bomb bay, reinforced fuselage, and twin-engine layout allowed engineers to reconfigure the aircraft for dramatically different missions without redesigning the entire airframe. That structural foresight became one of its greatest strengths. The extensive glazed cockpit, sometimes called the beetle eye by observers, provided wide forward and downward visibility, crucial for bombing and navigation. The mid-mounted wing offered aerodynamic balance and structural rigidity. Engineers balanced speed, payload, and structural integrity in a way that kept the Jumo V-12 competitive even as air combat evolved rapidly. Compared to contemporary medium bombers like the British Bristol Blenheim or the American Douglas A-20, the Jumo V-12 was often faster in early war years and more flexible in configuration. Against the larger American Boeing B-17 Flying Fortress, it could not match defensive firepower or heavy bomb capacity, yet it compensated with agility and operational versatility. It could dive bomb, torpedo attack, intercept at night, or conduct reconnaissance. In aviation terms, it was less a specialist and more a capable generalist. Its production volume, exceeding 15,000 units across variants, reflects both strategic reliance and industrial capacity. Surviving examples today are rare, with only a handful of largely restored airframes preserved in museums across Europe and North America. The aircraft's wartime legacy ensures that operational examples are not traded in civilian markets. Instead, preserved Jumo V-12 serve as historical artifacts, valued for educational and commemorative purposes rather than financial speculation. Before discussing valuation, we must pause to acknowledge the complex historical context. The Jumo V-12 was born in an era of intense geopolitical upheaval. It served in a conflict that reshaped the world. When we study such aircraft today, we examine them as engineering achievements and historical objects, not as endorsements of the ideologies they once served. Timmy once asked whether a restored Jumo V-12 could be used for vintage air shows. I told him that restoring a twin-engine World War II combat aircraft is slightly more complicated than polishing chrome on a Sunday morning. He nodded and returned to sanding something he probably should not have been sanding. In terms of economic context, the cost of producing a Jumo V-12 during wartime varied widely depending on variant and year, but it was estimated in the hundreds of thousands of Reichsmarks per unit. Converting historical Reichsmark figures to modern currency is complex due to inflation, currency reform, and wartime economic conditions. Modern museum-grade restorations of comparable twin-engine World War II aircraft can require millions of dollars in investment. Fully restored, flyable aircraft from the era often command values exceeding 3,000 thou at specialized historic aviation auctions, depending on rarity and authenticity. However, no complete flyable Jumo V-12 has recently appeared at major public auction, making precise market comparisons limited. Before we close, let us offer a moment of respect for the engineering teams who pushed materials and aerodynamics to their limits in a turbulent era. The Jumo V-12 was not perfect, nor was it invulnerable, but it represented technical ambition on a massive scale. So here is my final advice. When you see a historic aircraft like the Junkers Jumo V-12 in a museum, do not rush past it. Look at the rivets. Consider the scale. Imagine the sound of two V-12 engines pulling 30,000 pounds of aluminum and steel into the sky.